G'day kids, make sure you hit the subscribe button, that way you won't miss out on any of the new videos that come out. Until then, enjoy this one.
Ozzie, 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 oi! Ozzie is a friend of yours and he's a friend of mine.
G'day Ozzie. G'day Ozzie. G'day Ozzie. G'day Ozzie.
G'day kids, Ozzie here. Now who loves science? That's good, I do too, and that's why today we've come along to a place called Science Space, and we're going to go inside and meet a science expert that's going to take us through a super cool experiment. Now I cannot wait to get inside and check it all out. So come on kids, let's get stuck in. What? 3, 2, 1. Kids, in here is where all the fun happens. So this is where the science experiments are going to take place. We're going to go inside and meet a scientist called Robbie. He's going to show us so much cool stuff. So come on, let's go. Come on. Oh, look at this place. G'day, Robbie.
Hey Ozzie.
Nice to meet you, mate.
Nice to meet you too.
Thank you so much for having us here today.
Oh, no worries. It's a pleasure to have you.
Thank you. So you've got a lot of things set up here.
I sure do.
Where should we start?
Well, I think we should start with some sound effects. Let's talk about sound, shall we?
We shall.
All right. So our first one we're going to look at, we've got a little tuning fork and a little hammer, so we
Okay.
can make a sound.
Yep. I like
And
it.
sound is all about vibrations. The most
Okay.
important thing to remember. Anything that vibrates, going to make a sound.
Okay.
And usually we can't see these vibrations because it's traveling through the air. You can't see the air. So we're going to give it something that we can see to travel through.
Okay.
So we've got a glass of water here. We're
Yeah.
going to see if we can make a sound in the water. We'll see if we can see that sound.
All right. Whee!
Look at that.
That's cool.
Right.
So that's science happening. That's sound.
Yeah, that's sound that you can see right there.
Sound that we can see.
Yeah.
Amazing. I like that one.
Yeah, it's a pretty cool one. And some people might have seen it before in a movie like Jurassic Park when this T-Rex is stomping up.
Yeah.
That's the sound traveling through the earth into the little cup of water in the car.
Of course.
Yeah.
All right. I like it. So we've got some more sound.
We sure do.
Yeah.
So this one, we're going to try to make some sounds louder.
Okay.
So the whole point of sound is you can hear them. What's the point of a sound if you can't hear it?
Of course. Yeah.
Like this slinky, if I drop the end, it's pretty quiet. You
I
can't
can hear
much.
it, but not. Yeah, it's not really loud.
So, like we said, sound is all about vibrations.
Yeah.
So to make a sound louder, we can give it more stuff to vibrate. So I've attached a little cup to the end of my slinky here.
Okay.
Let's see if we can hear the sound a bit better when we drop it on the ground now. Like a laser gun.
It's like a laser gun.
It is.
That's really cool.
That's how they make all sorts of sound effects in movies. Whenever they have a laser gun, like in Star Wars, we don't have actual laser guns to record the sounds of.
Right.
So we need to use something like this to make a sound for the movie.
That really sounds. If you close your eyes and you listen to that, it does sound like a laser gun.
You might as well be there.
That's amazing. What is this? It's got some power. So, is it dangerous?
Oh, it is. So we need to be careful. We need to not touch this top bit here when it's on, otherwise we will electrocute ourselves.
Well, we don't want to do that.
We absolutely do not
Safety
want to
first,
do that.
as always, kids.
Always.
What actually is this?
Well, this thing here is a Tesla coil. So we put some electricity in through it. We've got a bunch of coils of wire in here.
Okay.
And right out the top here, we shoot out lightning.
Lightning at the top.
We sure do.
I am excited to see this one. All right, so you want to show me how it works, Robbie?
We just flick a switch.
Whoa. Wow, that is cool. So we definitely don't want to touch that, do we?
Absolutely not.
No. All right, so what do we do with that? We can see that electricity is coming out the top. Can you make those electricity bolts bigger?
We can, but we need to give our electricity something to jump into. So it
Okay.
doesn't like going through the air very much.
Yeah, and I don't want to put my hand in there because it'll probably jump into my hand and that's going to hurt
Absolutely
me.
not. What we do or what electricity loves to travel through, is something like metal.
Okay.
So we can use our nice high-tech bit of equipment here
Yes.
to give our electricity something it wants to jump into.
Okay.
And we do that just like this.
Now that is cool, Robbie.
It sure is.
That's amazing. And it's loud. It's like a lightning bolt. Is that essentially the same as what a lightning bolt is in the sky?
It absolutely is. It's just a small version of a lightning bolt.
Okay. Very, very cool. All right, Robbie, so we've seen how that electricity bolt jumps from the top of here into that, that metal that you were holding. But I noticed here that you've got a light globe. Now, what do we do with that?
Well, I'm sure you're familiar with lights in the ceiling.
Of course, yes.
They're run by electricity.
Yes.
And we've got some electricity here, so why don't we see if we can turn on our light globe without connecting it to anything.
Without connecting it to anything?
Not a single thing.
Okay, now this is a bit more magic.
Well, it's still science.
It's not magic, it's science, of course.
It's absolutely science.
All right, so let's see how this one goes.
All right, well, if we just hold it nearby, turn it on.
So that's this machine turning on that light.
It sure is.
Because that electricity is traveling through the air and turning on. Is that how it's working?
Yeah, it's enough to turn on our light bulb. But if we move it a bit further away,
Okay.
it doesn't like to go through the air very much.
Yeah, cool. So Robbie, those lightning bolts and that light turning on looks incredible with all these other lights on, but if we kill those lights, turn them off, I reckon that's going to look better, right?
I think it'll look so much better.
All right, let's turn those lights off. And let's try again, shall we?
Let's see how it goes, shall we?
Look at that. That's really cool. Wow. That is really, really cool, Robbie.
It's so much fun and it's so cool.
I love science. Now, I'm loving these science experiments and these tricks that you're showing me. But when I came in, I did notice that you've got some other stuff over here.
Oh, I sure do.
Now, do you want to show Ozzie and the kids at home what all that is?
I would love to. So
Okay.
we're gonna check out some liquid nitrogen.
Oh, wow.
So always important, safety first.
Of course.
And liquid nitrogen is super cold. It's negative 196 degrees. So I'm gonna stick on my safety glasses and my safety gloves to help protect me.
Yes, absolutely. Well, we don't want to get that liquid nitrogen in our eyes or on our skin, right?
We absolutely don't. That
Okay,
wouldn't be
so-
very fun at all.
Maybe I'll just take a little step back, shall I?
Absolutely. It shouldn't splash very far though. You should be safe.
Okay, good.
So we have our liquid nitrogen. Very cold.
Oh, yeah.
Outside, nice and insulated, so it's not too bad. And if we pour some out on the ground,
Oh, wow.
we won't touch this spot here because that'll be very cold.
Yeah, okay, wow. So that looks really cool.
Yeah, so it's so cold, it's evaporating as soon as it hits the ground.
Right, so that's what that smoke-like looking stuff is.
Yeah, well, actually, that smoke-like looking stuff, it's exactly what it looks like. It's clouds.
It's clouds.
Yeah.
Wow, so that's exactly what is floating around up in the sky?
Absolutely. So there's always water in the air as a gas.
Right.
And then when we cool the air down, it all collects together, it groups up, and it forms into a cloud.
So that's what clouds are.
Yeah.
Nitrogen, liquid nitrogen.
Well, clouds are, anytime you cool the air down, you're going to get a cloud.
Right.
So if the air's going up, it's going to cool down, it's going to turn into a cloud.
Right, okay, I'm with you. All
Absolutely.
right, so
And
what's
now-
next for this experiment?
Well, we saw it evaporating, turning into a gas, and one thing we love to fill up with gas is balloons. So we're going to see if we can pop a balloon with our liquid nitrogen.
Oh, great. Now this is going to be cool, kids. I'm super excited.
Oh, this one's so cool. So we're going to start off, we're going to stick some liquid nitrogen in our bottle here, help us catch it.
Okay, so it's not evaporating inside the bottle, is that right? Or it's just doing it a little bit slower?
It is doing it a bit slower because we
Okay.
have a nice big group of it.
Okay.
So it's all staying a bit colder.
Okay.
And we're going to stick our balloon on top to catch all that nitrogen gas that's evaporating.
All right, so it's not the liquid that's going to go into the balloon, it's actually the gas.
Yeah, so we're going to make that liquid nitrogen in the bottom, we're going to make it evaporate, turn into a gas, and it's going to fill up our balloon here.
Wow.
So I'm going to stick on my earmuffs.
Okay.
If you could block your
I'm going to
ears on
stick
me,
my earmuffs on too.
because this one's extra loud.
What?
So there goes our balloon. We'll just pour out the rest of this liquid nitrogen.
That is amazing. That is super cool. And look what it's done to that balloon.
Our balloon is completely shredded.
That is super cool, Robbie. That balloon has just been absolutely shredded.
It has.
That's crazy. So you put the bottle inside, that's just water there?
Just regular water.
Yeah, and what is that doing to the process? How is that making that balloon blow up quicker? Because that's what it looked like it was happening.
Yeah, so we saw our liquid nitrogen was evaporating super slowly. So if I stick it in there, that just helps our liquid nitrogen evaporate even quicker.
Right.
And so that's going to help fill up our balloon even faster.
Why was it so loud?
Well, we know that this isn't what a balloon usually looks like when it
Yeah.
pops. Usually when you pop a balloon, one spot splits and the whole thing tears around from there.
Yes.
So we know that sound's vibrations.
Yeah.
And so only one spot on the balloon's usually making vibrations. But this one, completely shredded.
Okay.
So we have a bunch of spots tearing all at once.
Right.
So it's like a bunch of balloons popping all at the same time. So it's
Okay.
extra loud.
So lots and lots of noise happening all at once because it's popping in all those different places.
Absolutely.
Yeah, cool. Robbie, you've got another experiment that you're going to show me now, is that correct?
I sure do.
Using liquid nitrogen again?
Using liquid nitrogen again and another balloon.
Okay.
So what we're going to do, we're going to stick our liquid nitrogen in there.
Okay.
And we're going to grab a nice pair of tongs because we're going to be pouring some liquid nitrogen over the top of this balloon.
Very cool.
And we don't want to be touching it with our hands when it's super cold.
You freeze your fingers, right?
Absolutely.
Yep.
So we're going to stick these gloves back on. And we're going to grab our liquid nitrogen.
Okay.
And we're going to see what happens to our balloon when we pour some liquid nitrogen on it.
I can't wait.
Well, you don't have to.
Oh, no way! What's happening to it?
It's shrinking.
It's incredible. It sounds like it's turning into paper.
Yeah.
So it's not popping, it's shrinking.
It is. It's shrinking down, getting nice and small.
And is that becoming hard, like plastic?
Yeah. So when we cool down our rubber, it's going to become a lot more brittle. It's not going to want to move around as much and as easily as it used to. So our balloon's just going to crinkle up nice and small like this.
That's very cool.
And then if we take it out of our liquid nitrogen, we let it heat up. Maybe we can help speed up the process. Ozzie, if you want to blow on it for me.
What? I'm blowing up a balloon from the outside.
From the outside.
That is absolutely mind-blowing.
It's very cool.
I've never seen anything like that, Robbie.
Well, I'm glad I could blow your mind a little bit.
Yeah, you've certainly, well, you've blown up a balloon and you've blown my mind and the kids at home, I've no doubt. Now, is that cold?
Excellent.
Can I touch it or?
You can touch it. Rubber's not a very good conductor, so we can touch cold rubber.
Yeah, so that just feels like a normal balloon again.
Yeah. So
That
when we...
is incredible.
It's so cool.
I'm absolutely blown away, to be honest. So if I put that back in there and we pour more liquid nitrogen on it, it would just do the same thing again, shrink again.
It'll shrink down and then it'll blow up again when we pull it out.
We try it.
Do you want to pop it back in there? All right,
I'll let
let's
you use
see.
your tongs. I like my fingers as they are. Unbelievable. So that is the exact same balloon that's been blown up, shrunk down, blown up, and shrunk down again.
And we're about to blow it up again.
And we're going to blow it up again.
It's had quite the journey, this balloon.
It's had quite the journey in the last couple of minutes.
All right, there's our shrunken balloon.
I'm going to blow it up from the outside again. Robbie, what do you reckon?
All right, give it a nice big blow.
That just simply is one of the most incredible things I've ever seen.
Well, I'm glad you like it.
Yeah, that's really cool. Kids, did you love that? That is pretty cool, isn't it? What else can you freeze using liquid nitrogen?
Well, we can freeze some living things.
Okay,
So we have a flower here,
yes.
and we're going to try and freeze this, and we're going to see what happens to it when we freeze it.
Oh, I can't wait to see what happens to it actually. Is it going to grow
Alright.
bigger? Is it going to go smaller?
Who knows?
We're going to find out, aren't we, kids?
Actually, you know what? You can do something on this one.
Ooh, I'm excited.
So I'll give you these gloves.
Yes.
That you can stick on at some point, and these
Yes.
safety goggles.
All right, I'm becoming a scientist. The longer I stand next to you, Robbie, the closer I am to becoming a scientist.
It's rubbing off on you.
It is. All right, got my gloves. Got my goggles.
All right, so Ozzie's gonna give me a hand with this one. So
Perfect.
we're gonna freeze this flour. We're gonna stick it in our pan here.
Okay.
And we're gonna pour some liquid nitrogen on it.
Oh, that looks pretty cool.
Let it cool down.
A lot of bubbling happening in there, Robbie.
There he is.
Is it cooking it?
What we're gonna do, if you can hold your hands out for me, Ozzie. We're gonna drop some of these in there. We're gonna stick that in there as well.
Man, that feels really crusty.
And we're gonna stick one more in there. And do you want to give them a nice big clap?
You want me to clap the flour?
Clap.
What just happened to the flour?
It popped.
That's the end of the flour there. So we've frozen it. It's become super hard, and then you can just crush it.
Yep.
Wow. This liquid nitrogen stuff is super fun. It's so much fun, Robbie, that I'd love to get some for myself and do some of these experiments at home. Can you do that?
Well, it would be pretty hard to get for yourself. That's why you come here, watch us do it.
Okay, and where do you actually get liquid nitrogen?
Well, we make this one ourselves here at the university.
You make it.
Yeah.
It's incredible.
To make it, we just take the air, because the air is mostly nitrogen,
Okay.
and we cool the air down. We put a whole bunch of pressure on it, we push down on it, and all that nitrogen in the air turns into liquid nitrogen for us to do cool experiments with.
It is very, very cool. Now, I have noticed one more thing. You've got a leaf sitting over here.
I do have a leaf.
Are we going to do the same thing as we did to the flour?
We sure are.
Oh, I can't wait.
So let's dip our leaf into our liquid nitrogen
Oh,
here.
you're going to dip it in, okay.
And we're gonna let it freeze the whole leaf.
Oh,
And I'll stick this one in your hands, and you can give us a nice
no
big
way. Check
clap.
that out. You can see how hard it is. All right, so I'm going to clap it, and we'll see what happens, kids. So it's broken apart. It's shattered like a light bulb or something, like glass. It's just absolutely shattered in my hand.
It sure has.
So, Robbie, you've got another one set up here. I can see some lighters, so I'm presuming there's going to be some flames, some fire involved.
There's absolutely gonna be fire.
Okay, we'll talk me and the kids through what we're going to do here.
So what we're gonna do is we're gonna make some bubbles. We're gonna fill those bubbles up with a flammable gas.
Okay.
And then we're gonna set those bubbles on fire.
Wow.
But we're gonna take it a step further. I'm gonna take a big scoop in my hand and set them on fire there. How's that sound?
It sounds very dangerous.
It sure is, so please don't try this at home. I have my safety equipment here.
Yep. Safety first, and
Absolutely.
and leave it to the experts, the actual scientists. I'm certainly not going to get involved in this one. I'm going to take a bit of a
Absolutely.
step back to keep myself safe.
And I do have my fire blanket, which Ozzie can put me out with
Perfect.
if I light myself on fire.
That's
which
my job.
I won't.
Okay. No,
So-
you've done this a few times, I'm sure.
Well, I've done this so many times, and it's so fun every time.
Good. Awesome.
So I'm gonna stick my nice big apron on. This will help me stop my clothes from catching on fire.
Great.
Tie it up, there we go. I'm also gonna wear this nice big face shield to stop my face from catching on fire.
Very important.
And the last thing I'm gonna do to keep me safe is I'm gonna spray my arm with water.
Okay.
And so the water, it's gonna soak up all the heat from the fire, and that's gonna stop me from getting burned.
Yep. Well, that's
Keep
a good
me
thing
nice
too.
and safe.
Yep.
So we'll spray my arm down with plenty of water. There we go, that should be plenty.
Nice.
And we're gonna make our bubbles.
Ah, wow. Wee. That's fun.
All right, and now we're gonna stick the face shield on. Get a nice big handful, big as we can. And we're gonna set them on fire, ready?
Wow, that is awesome. It also looks very dangerous, but as I said, you're the expert here.
I am
You know
the
what's
expert.
happening. Do you reckon we can do that with the lights off?
We sure can.
Oh, I reckon that's going to look pretty cool.
Let's do it. All right, so we're gonna make some more bubbles. We're gonna spray my arm with just a bit more water because some of it's evaporated now after the first fire.
Yeah.
Face shield back on. Big handful. And ready.
This is so cool. This is the best day ever. These experiments are simply amazing. They're, honestly, you really do have the best job.
It's the best job in the world.
You're a lucky man. Now, Robbie, I just want to say thank you so much for allowing Ozzie and the kids to come in and check out all these amazing experiments.
No worries, it was a pleasure having you guys here.
Yeah, what a cool job you have. I'll tell you what, maybe I'm going to go back one day and restudy and become a scientist. Kids, hopefully this has inspired you to come along and check out these experiments firsthand at Science Space. I hope you've had lots of fun, hope you've learnt lots. We'll see you on our next video. Until then, stay keen. Keep experimenting, keep having fun. Hey kids, did you have lots of fun today watching Ozzie? I hope so. Did you know that we've got a heap of Ozzie episodes on our YouTube channel? If you haven't already, go back and have a scroll through. I reckon you'll find some others that you absolutely love. And while you're there, why don't you hit subscribe? That way you won't miss out on any of our new videos that we bring out. We'll see you again soon, kids. Until then, stay keen. Oh, and by the way, did you happen to find the hidden Ozzie icon in that video? Yeah, make sure you look closely because they're in every single video. That's right. Stay keen, kids.
Ozzie, 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 oi! Ozzie is a friend of yours and he's a friend